Hi Year 11s, this lesson's on Pythagoras' theorem, which you've done before in previous years. So, reminder, Pythagoras' theorem, it's about, it can only be used for right-angled triangles. So in your journal, now if you're using a journal from previous years, you probably already have it there, but if you're using a new journal, go and add the Pythagoras theorem to it. Please draw a right-angled triangle. Your right-angled triangle must indicate that it's a right-angled triangle, just like I added on the screen there. Please write down A, B, and C. Doesn't matter where you label A and B, which ones you call A and B, but C is important. C is always the hypotenuse, okay? So hypotenuse, and it's always the longest side of a right-angled triangle. Always that one. And it's on the other side of the right angle. Okay, hypotenuse, longer side. If you're wondering what are these sides called, they're called legs. Right? It's not a term that's commonly used, but they're called legs of a right-angle triangle. Now, the Pythagoras theorem, it goes like this: c squared equals a squared plus b squared. Now, I'm going to rewrite it with the a squared plus b squared on the left-hand side. So please write down both of those. They're the same rule, but please write down both of them in your journal, because sometimes it's easier to use one, sometimes it's easier to use the other one. Let's go and do a couple of examples here. This one here, it's asking us to find the unknown length and to express the answer correct to three significant figures. We have a right-angled triangle. Yes, we do. We have legs 3 and 6. This is the missing length there. Let's call it x. And now I'm going to label the sides A, B, and C. C, there's no choice. I must label that one C, because it's the hypotenuse, other side of the right angle. As for A and B, as I said, it doesn't matter. Let's call that one A and that one B. Now, we have to ask ourselves, are we trying to find A, B, or C? Okay, we're trying to find C. Since I'm finding C, C is on the left-hand side of the formula here, the theorem. This is the one I'm going to use. So it's easier to use a formula that has the unknown on the left-hand side. Okay, just makes it a little bit easier. So let's go. I'm going to write down the formula. C squared equals a squared plus b squared. Oops. And now we substitute. Instead of c, we put an x. So we have 3 squared, plus 6 squared. If you put in your calculator 3 squared plus 6 squared, it will give you 45. And the opposite of squaring is square root. So because at the moment we have a square there, we want to have x by itself. We do square root of 45. And if you have your graphics calculator, go and get it and type in square root. So square root, we go shift. There's a square root there, so square root. We put 45, and notice that it gives me 3 square root 5. But I wanted to have 3 significant figures. So if I go and press this button here, and look, depending on your calculator, it might say SD, but it's this one there. I go FD, and this is now in decimal form. 3 significant figures does not mean 3 decimal places. It means 3 digits counting from the left. So 1, 2, 3. I cut it there, 6.70, but you have to be careful. Go 1 place more, it's an 8. Ah, yes, it's 5 or more than 5. Yes, it is that 8, so that becomes 6.71. So we go x is equal to 6.71. Let's not forget our units, which was in centimeters, and we're going to put in brackets. That was correct to 3 significant figures. So it's not exactly 6.71, but if you go 3 significant figures, it is 6.71. So you might like to copy that one down in your journal. And here's another one that we're going to do next. So another right angle triangle here. Have a look at the triangle. Do you notice anything special about it? Other than being a right angle triangle, of course. Look at those numbers. We have 7 what? Centimeters. Then we have 110, but 110 millimeters. They're different units. So the first thing is, let's convert one of those sides into the same unit as the other one. I reckon if we go from here, we change that one into centimeters, be the easiest one, as in it'll be like the nicest numbers to deal with. So that's equal to 11 centimeters. And that's what number that we're going to use, 11. Okay. Next, we label the sides as A, B, and C. This is the hypotenuse. I'm going to have to call it C. Remember how I said it doesn't matter which one you call A and B? Now, if you're trying to find one of the legs, go and label the unknown one as A and the other one as B. All right, that's the first thing. Now, let's go back to our formulas here. We're trying to find A. A is not on the left-hand side in that one, but it is in this one. So let's go and use that formula instead. So we go A squared plus B squared is equal to C squared. And now we substitute. We put X squared plus 7 squared is equal to 11 squared. Now, we want to have X by itself on the left-hand side. So this plus 7 squared, let's move it to the other side. Let's go X squared is equal to 11 squared was here. How does plus 7 squared go to the other side of the equal sign? Well, it was plus before, becomes minus now. So minus 7 squared. If you put it in your calculator, oops, that's not looking very nice. We've got X squared is equal to, if you type in 11 squared minus 7 squared, I'm putting it in my calculator now, we get 72. Opposite of squaring is square root. Put that in your calculator, do square root 72, and I am getting X, if I go 3 significant figures, that's 8.49 units, centimeters, and that was 3 SF. So once you're done, copy this one in your journal. If you are going to copy it down, please go and do these questions in your exercise book, not in your journal, in your exercise book. And once you finish with those ones, then please go and watch the next video.